In this lesson, we're going to continue working with the triangle angle sum theorem and isosceles triangles, but we're going to add some algebra. So in the previous lesson, we just dealt with numbers. The interior angles of a triangle add up to 180 degrees. And when you have an isosceles triangle, when you have two sides that are congruent, that automatically means that two of the angles, the angles that are opposite of those sides, they're going to be congruent too. So we look at this problem, and I want to find the value of the missing variable. So I want to solve for x. Well, I see that triangle, and instantly, when I'm talking about the angles of a triangle, you need to consider that it could be the sum of the interior angles is 180, which it is. So that means this plus this plus this is equal to 180, or part plus part plus part is equal to whole. So 2x plus 3x minus 18 plus x minus 12 equals to 180. This goes back to everything that we've been doing since the beginning of geometry. Part plus part plus part equals whole, and the whole is 180. So now this is algebra. Just combine your like terms. 2x plus 3x plus 1x is 6x. Negative 18 minus 12, or negative 18 plus a negative 12, however you want to think of it, is negative 30 or minus 30 equals 180. So we take the 180, we're going to add 30 to both sides. Remember, you can pause this video at any time if you need to get caught up. So 210, then we divide both sides by 6, and we get that x is 35. If I had asked you to, you could go back up here and you could say, okay, 2 times 35 is 70, so that angle is 70. 3 times 35 minus 18, so 3 times 35 minus 18 is 87, and 35 minus 12 is 23. And if you were to add 70 plus 87 plus 23, you would see that those angles add up to 180. But I didn't ask for that, but just so you know that you can. Again, we've got a triangle. Those add up to 180. So we take our x plus 20 and our 5x and our 40. Don't worry about what you're going to do with it yet. Just write it down first. Then start dealing with it. Combine your like terms on the left-hand side. 1x and 5x is 6x. 20 and 40 is 60. That equals to 180. Subtract 60 from both sides so that you can solve. You got to do the inverse. 180 minus 60 is 120, which means that x is 20 when you divide both sides by 6. Okay, so x is 20. Now I wanted to go further, and I wanted to ask how big angle W is. Well, angle W is x plus 20. X was 20, so it's 20 plus 20. So angle W is 40 degrees. And then angle V is 5 times x, or 5 times 20, which is 100. And you can double check. 40 plus 100 plus 40 is 180. Now when you get to this one, you'll notice that I only gave you 2 angles. Well, you can't just leave it off, right? You have to have something if you're going to use the sum of the interior angle theorem. So there must be some other way to do this problem. Well, this information is given to you for a reason. That means that those two sides are the same. If those two sides are the same, then these two angles, the angles that are opposite of those sides, they are the same also. So since they are the same, that means this piece equals this piece. Basically, what we want to know is what does x have to be so that that other angle can also be 68, because this angle needs to be 68 also. And I want to know what value of x lets that happen. So I take 68 and I divide it by 4 because I got to do the inverse, and you get that x is 17. And that allows 4 times 17, let's just do a quick check, let me show you, that's also 68. So x has to be 17, and if it is, then that angle can be equal to the other one. Okay, same thing here. This is another way of me telling you that these two sides are congruent. I've given you measurements. That information is there for a reason. I don't need it to solve the problem, except that I need it to recognize that this is isosceles, which means this angle equals this angle. That means this equals this. So just write that down. 4u minus 7 equals 2u plus 15. Don't worry about what you're going to do with it until you get it written down, because now you see the algebra problem. So we draw our line down. We're going to solve our algebra problem. We're going to subtract 2u from both sides and get 2u minus 7 equals 15. Then we're going to add 7. We got to do the inverse. Add 7 to both sides. And we get 2u is equal to 22. Do the inverse, divide by 2 and divide by 2, and we get that u is 11. I could plug in that 11, 44 minus 7, and 22 plus 15, and you would get the exact same answer. Now, notice this one. This one's a little more complicated, and your tendency is going to want to be to set these equal to each other, because that's what we've been doing. But notice that these two angles are different, right? This is the vertex angle, and this is the base angle. Okay, this top angle right here in between the two congruent sides is the vertex angle. This angle is the base angle. They're not equal to each other. The base angles are equal to each other. So let's find the other base angle. Those two are the base angles. They are the angles that are across from the sides that are congruent. Now here's why that's important. Because if this angle is 2x, this angle is also 2x. Now I have enough information to set up my problem. So now I have three angles of the triangle. So 2x minus 24 plus 2x plus 2x is equal to 180. So 2x plus 2x plus 2x is 6x minus 24 is equal to 180. Okay, so 180 plus 24, add 24 to both sides right here, gives you 6x is equal to 204. Divide 204 by 6, and you get that x is 34. And so if x is 34, then you get that this one is 68, this one is 68, and the other one is 68 minus 24, which is 44. So this one is 44. I didn't ask for those, but I just want you to remember that you are able to find them if you are asked for them. Be sure that you always answer the question that you were asked. Okay? Now, here's a little bit of a word problem. So we don't like word problems. That's okay. We're going to change our word problem into a drawing, just like we've had. So I start here. If ABC is isosceles with vertex angle A and base angle B, what is x and the measure of B? Okay, so here's what you want to do. Go back and read it again. If ABC is isosceles, so first thing I'm going to do is this. I'm going to draw myself an isosceles triangle with vertex angle A. Here's my two sides that are congruent, and remember that your vertex angle is up there in between the two congruent sides. So we have a vertex angle A and we have a base angle B. Vertex angle A, this angle is 2x plus 40. And angle B is 5x plus 16. Now, if you look at this, this should look very familiar. This is exactly what we just got finished doing. I have a vertex angle and a base angle. So we've got to double up that base angle because there are two of them. The base angles are the same because the sides are the same. So I have base angle plus that angle. If you have all three angles, you can add them up and set them equal to 180. So I'm going to shortcut this just a little bit to save us a little bit of time, but I'm going to do 5x plus 2x, that's 12x, and 16 plus 16 plus 40 is 72. And that equals 180. It's 5x plus 16 plus 5x plus 16 plus 2x plus 40 equals 180. Okay, do the inverse of plus 72. So we take 180 and subtract 72. We get 108, so 12x is equal to 108. The inverse of multiplying by 12 is dividing by 12. So we're going to divide by 12, and we get that x is 9. Now we go back and we make sure that we've answered the question that we were asked. If ABC is isosceles with vertex angle A and base angle B, what is x? Did that. And the measure of B. Okay, we need the measure of B. So the measure of angle B is 5 times 9, 5 times x, plus 16. So 5 times 9 plus 16. So we've got our 9 times 5 plus 16, and you get that angle B is 61 degrees. So those two answer the question. Now that's dealing with the angles of triangles and isosceles triangles with algebra. Let's do one more thing. Let's do the converse. Remember, converse is you switch the order that they're written in. Right? The converse was if Q, then P. So we said if the triangle has two congruent sides, then it has two congruent angles. Okay? The flip of that, or the converse of that, says if two angles of the triangle are congruent, then the sides opposite them are congruent. So I can know that it's isosceles. The two congruent angles are the base angles. So I can know that a triangle is isosceles because the two angles are congruent, which means the two sides are congruent, or I can know it's isosceles because the two sides are congruent, which makes the two angles congruent. So if D is congruent to F, what this is saying, that is if D is congruent to F, if angle D is congruent to angle F, then the sides opposite them, EF and DE, are congruent. So this is still true. You always have that picture when it goes together like that. Now the value of that is this. Find the value of x. These two angles are congruent, which automatically tells me that these two sides are congruent. Part equals part. So 2x minus 3 equals 9. And now your algebra problem is set up. That's the geometry part. Add 3 to both sides. You get 2x is equal to 12. Or x is equal to 6 if you divide both sides by 2 after that. Okay, same thing here. You have these two angles are congruent, which means these two sides are congruent to each other. That means this side, this part, equals this part. 9x minus 24 is equal to 4x plus 36. I like to always move my smallest x so that it can be on the same side, so I'm going to move it first. I like to move my variables first. I always do that. Minus 24 equals 36. I'm going to add 24 to both sides. That gives me 5x is equal to 60, which gives me, then divide by 5, which gives me x is equal to 12. From there, I could find my side lengths. I could substitute that back in and find my side lengths. So similar to yesterday, the sum of the interior angles of a triangle add up to 180. The base angles are the angles that are across from the two sides that are congruent, and vice versa. The sides that are congruent are across from the base angles. Okay, so you can use them back and forth to be able to use isosceles triangles to solve problems.